Hi, welcome back to the Metabob Podcast. My name is Klay Avi. I have alongside me Avi Gopal, CTO here at Metabob. And we also have a very special guest, Yuan Shen. Yuan is the founder and CEO of OneClick.ai, an augmented forecasting and optimization platform that enables enterprises in both retail and consumer packaged goods to achieve fast time to value on-demand forecasting and dynamic pricing solutions. Yuan and OneClick were TechCrunch's Disrupt's top pick for AI and machine learning in 2019. And Yuan has written multiple articles about his work, even showcasing OneClick's contributions in Forbes. Yuan, we are so happy to have you on, man. Welcome to the show.
Hi, thanks for having me.
Absolutely.
Our pleasure.
Absolutely. Thanks for being here. So Yuan, I would like us to start by you telling us a bit about yourself and your background. How did you get into AI?
Yeah, so when I started to study AI, it was not like nowadays, if you go to classroom learning, machine learning 101, it's just packed with people. At the time when I was studying, it was only few people, and we don't see very robust application at the time. That was actually almost 17 years ago. At the time, I was actually accidentally getting involved into medical application. So was actually taking the CT scan, trying to use certain computer vision technologies to do 3D model reconstruction. That was actually my undergrad project. So I really like, apply those interesting technology in the medical field. That's why later on, I go ahead pursue my PhD degree in the biomedical field. That is actually the joint program with the biomedical department, with the computer engineering department. So essentially over there, what I was doing is actually building a more like image guided system to help the surgeons to remove the tumor within the colon. Obviously at that time, we use machine learning to do certain feature extraction on those 3D medical images, and also using some of the interesting technology nowadays you see on the self-driving vehicles, SLAM type of technology. So essentially you can think of when we finish a CT scan of a patient's colon, so we do the 3D reconstruction, we know the environment, then we know exactly what the tumor is, then now it's a time to help the surgeon to remove those type of things. But the challenging thing here is because once they insert the equipment into people's colon, then the colon is going to deform. So it's a little bit different from like self-driving vehicles because it's a fixed environment. You know exactly how many buildings around you, what's the distance. So at the time, I think, well, probably, first, few groups try to tackle the problem. And essentially it was actually a very interesting project. So I really get a chance to use a lot of machine learning technology, computer vision. And essentially after the program, I was decided to continue to pursue a career, applying computer vision, machine learning, on other interesting applications. That's how I get started.
That's fantastic. So I know this because I did a bit of research before the show, but where did you go sort of after your work, your research studies?
Yeah, so afterwards, I was actually has been recruited by Microsoft. At the time it was early 2010. At that time, they were actually trying to using massive scalable machine learning system on their search engine, right? At that time, I think that Google and Microsoft was actually in the search engine war. Obviously, Google has a lot of advantage in terms of market share. I think from technology perspective, Microsoft, I think they actually took one step even further. So basically, everything is driven by the machine learning system. We don't like to use rule-based type of system, right? So essentially, I was actually joining the team who is actually building the, we call query relevance model on multimedia, basically image and video. You go there, you search certain keywords, and we try to return the relevant images, videos. And that's basically, at that time was driven by a lot of machine learning technologies and as well as computer vision. So that's actually, we'll actually apply those things in real industry application. So afterwards, I also spent a few years actually joining eBay and actually was able to manage to take the deep learning technology into their C2C flow and help them to make the listing process. If you try to sell something on eBay, much easier, and you don't have to tell the system how big the item is. We'll basically use natural language processing to figure out what type of object it is and how big they are, what kind of shipping services, and in the whole process, try to really make the listing as simple as possible, rather than they spend more than like 15 minutes to finish the listing. Right, this is definitely can increase the listing completion rate, and we have seen about roughly about 2 point GMV lift, which is very significant in terms of the revenue wise. So,
wow, that's incredible. And then your bouts after eBay inspired you to become an entrepreneur, if I understand the timeline correctly. So then you began the sort of work for OneClick, and so that's kind of where the bulk of our conversation will be today. And so, yeah, why don't you tell us a bit about OneClick and how it works?
sure, yeah. So before we work on this project, so obviously I work on different projects relatively, dealing with bunch of images, some videos, also structured data basically. And at that time, I think one of the challenging point is we have seen technology is moving very fast. And obviously the big companies, they already take advantage to apply those things into their products. But if you look at the other segments like manufacturing, retail, they're still behind the curve. So obviously at that time, we're thinking finding a data scientist here is relatively challenging, even nowadays, right? Because the problem is getting more and more complicated. So obviously finding the right talents is no easy task. So at that time, we're thinking about, is it possible for us to really build something relatively generic that we can help not only the technical folks, also a lot of non-technical business users to be able to quickly use AI technology into their day-to-day operation. That's how we started to form the idea to try on this. But at the same time, so obviously I'm more like a product person, and obviously I try to build something that can be differentiated from the rest of the market. At that time, we already seeing few companies working on certain AI toolbox, helping those data scientists to build those models relatively easier. And by that time, they majorly focus on structured data, basically a bunch of numbers, numeric numbers you can get from database. So we try to use even bolder approaches. What if we focus on unstructured data sets? As we know, 85% of data sets within enterprise, they are actually unstructured, emails, voicemail, notes, images, etc. So when we began to build our technology stack, we try to spend more time to try to tackle the problem. How can we make use of those unstructured data? How can we make the modeling more easier, more adaptable to deal with those type of data?
That seems like, to put it mildly, a daunting task to sort of try to create something from nothing, in a sense, and predict the future like that. Where, I mean, I'm just curious, where is this data coming from? Like, how is the data being predicted? Like, more specifically about the tool.
Yeah, so doing forecasting, obviously, there's a lot of interesting applications we can tackle. As you know, in the machine learning worlds, you see a company is working on specific customer retention, prediction churn, and you see other companies they doing maintenance prediction and click prediction in advertisement. There's a lot of different, a lot of application you can apply machine learning, those sort of interesting technology. Essentially, what we actually end up is we try to apply the technology into the forecasting work, because forecasting has been around many decades. Mm-hmm. I think obviously financial industry they try to deal with the numbers for a long time. So it's existing market. Obviously forecasting not only apply to the financial. You have seen companies in the supply chain that dealing with a lot of numbers because they need to understand market demand, so they can prepare the better production planning, replenishment, inventory optimization, stuff like that. And also for marketing department, it's the same thing. I'm actually going to running the marketing campaign because I want to make sure I spend the big bucks and also I get the real returns. So obviously they need to figure out which channel is more profitable, and if they spend X amount of money, how many clicks and how many conversions they can get. It still goes back to the forecasting problem. So we feel like it's relatively, I think the market has already been educated in that regard. But the challenging over there is at the time, we just don't have enough good models or good data to really improving the forecasting performance. So it comes from two folds. I think when we look at the AI, right? So I think a lot of people, they overemphasize the importance of the algorithm, the models, but essentially, I think the data is even more important from that perspective because, as you know, garbage in, garbage out. And obviously in the forecasting world, I think the trend is no longer just processing one-dimensional data sets, right? When we, for instance, when we look at the financial market, right, they're dealing with the stock price. Obviously, you can just look at that single curve, but essentially there are other factors involved: the news, the sentiment, the government policy, things like that. Basically, forecasting become really generic problem in terms of you can leverage a lot of data sets, and data sets that can be numeric, a bunch of numbers, a bunch of text, as well as some of the image or video data as well. So essentially, we decided to focus in the forecasting world. And obviously, as I said, as a stop, we want to focus a little bit more on specific segment. Essentially, we decided to focus more on the supply chain side across the segment of consumer packaged goods, as well as retailer.
I see. Avi, I guess this would be a time to reset, but I do have another question in mind, but I just wanted to throw it to you if you also wanted to. We can cut this, of course, but just if you had.
Well, most of my
okay.
questions here are, I guess I would want to go a bit more into exactly like your current like customer base or your target market that you're going for. Is this like something that you're heavily specified for in terms of your technique or the sort of models that you're using or implementing along with your auto ML methodology? Or is it like, what are the like scope of use cases that you can support if somebody was to install or set up OneClick right now?
Yeah, so obviously at this moment we majorly focus on relatively big enterprises. Some of my clients, including Goodyear, Coca-Cola, Colgate, those big enterprises. So when we obviously work on with those clients, so I think one of the first gap is how can we really convert the business problem into a technical problem that can be solved by the machine learning, right? So everything's starting from the data. Data is essentially very important. And if you look at those different companies, essentially they're doing one thing, basically forecasting the future demands. But essentially, you're going to see a lot of cross-learning opportunities when you work with different companies within the same segment, because they, it doesn't matter they sell sparkling water versus orange juice, they are drinks, right? There's certain patterns out there. So essentially, when we build the solutions, we try to do not only that is, we want to learn the patterns from that, from my client's data sets. And at the same time, we also see certain values if we are able to do certain cross-learning. But obviously, privacy is one of the important things. Obviously, I don't want to share my data with my competitor, right? So essentially, so we providing a mechanism. It's a program that my client can opt in or opt out, right? Essentially, once we look at their data sets, we try to see if we can generate certain derived data sets. And this derived data sets is more industry specific, right? That means if I land one client And if in the future, if I land similar clients, can I really use this derived information that can help me to learn better, right? So I'm obviously, I think this derived information comes from twofold. The first one is about which data is more important, right? If you look at, let's say, a beverage companies, they have their internal sales, promotions, whether do they impact by the GDP, all those type of things, right? So obviously, certain information is more important than the other ones. Can we really learn those things quickly, right? Instead of try everything, every combination that could take time, as you know, because I think the tendency in the machine learning world is people, they tend to try different things. But I think after they try certain things, definitely we can come up with a better system to be able to cross-learning the data, to be understand which one is more important, that we can focus to do less unnecessary work, right? This is more from data perspective. For the modeling perspective, I think it's the same thing, because essentially we try to build the deep learning models. Obviously, I would say we work with traditional machine learning model, statistical model as well, because I think you don't see a model that works 100% across the board, and really depends on patterns of the data. So if you see certain product right there, sales is relatively stable, and I think you don't have to use a machine learning model. Probably statistical model is actually good to go. And sometimes if you're dealing with multiple data sets and you see a lot of volatility within the sales patterns, I would say deep learning model might be a better choice. However, when people they try to build the deep learning models, there's a certain complexity within the model in terms of how can we consume the signals from different data sources, right? How can we do feature engineering differently? How can we build a different neural network architectures? And obviously, it's more like a graph type of model, deep learning, because they have a bunch of neurons that talk to each others. And essentially, it's not practical for us to try every combination to connect those different neurons, to try all those feature engineering mechanisms. So essentially, what we want to do is we work on the client data sets. Initially, we might try many things, but essentially, the more we try, I think the system should be able to learn a better pattern. So in the future, if we have similar data sets, we just have to have a better starting point to build the model rather than try every possible combinations out there. Essentially, that's how we approach client and how we approach their data sets and how we build a system that can iteratively improve by itself.
While we're on the subject of feature engineering, so when a client comes to you, you just ask them for all of their data, so even like internal emails or things like that, in order to try and better correlate different factors? Or do you have some like heuristics on what data needs to be provided to you? Or do you use some sort of like semi-autonomous technique to try and pare down, or from the learnings that you've had in previous applications, figure out which items are most relevant? And how do you construct a model for that?
Yeah, I think obviously when we initially approach the clients, obviously we will recommend certain data sets given the problem they try to solve, the domain they are in, and the expectation of the forecast accuracy. We definitely have a list of the data sets that we think that might be helpful. But essentially, when we figure out, even if we give the same list to the two companies within the same segments, right? Let's say they're both selling tires. Essentially, the data quality, the type of data sets that they can connect internally, combined with other external signals. I think the data quality is definitely different, right? So there's no way I can say if you provide X, I'm gonna see Y% forecast accuracy improve. Essentially, what we do is starting from the data first, rather than say, you give me everything. Let's say which one model picks the best. You can do that way, but you're gonna waste a lot of resources. And unless you can get a very good model at the very beginning, essentially, if you try to build a system that can iteratively, continuously improve, you have to go from the data to find out what the issue is, and can we use additional data sets to make it up, or I think the model needs to do certain customizations to make it work. So I think starting from data is very important. I'll give you one example. Let's say we obviously we're expecting certain seasonality when we look at those sales records, but sometimes we see like one-time events, maybe usually during the month of June, and the sales is pretty flat. But now this year, we see a big spike. But there must be something out there, right? If it's an outlier, great, we can just remove there. But usually I don't want to do that. So in this case, we have to talk with the team to understand what is the driving factor behind this spike. Is this one-time deal, or we're going to see them in the future, right? If they say it's one-time deal, then we probably can consider as an outlier. We correct the training data sets. We don't do too much on it, right? If they say, okay, we're going to see this thing next year as well, then I think it's good to really think about, can we really using their know-hows to generate certain features that can represent this spike that we can reuse in the futures. So in this way, we spend a lot of time with client initially, just work on their data, look at the qualities to see if we can find some outliers. If we do, can we make sense of them, right? Can we use other external data sets or internal data sets to cover information on those outliers? And then we'll worry about the models.
So in terms of the whole data cleanup, data collection process, there's still quite a bit of emphasis on human analytic capabilities to try and learn some of the underlying patterns within the domain, and then limiting the number of things you need to try using that technique. So for the rest of your process, or as you're building it out, are you planning on moving towards a more auto ML type solution based off of the learnings that you're getting from doing these initial offerings, or what's your plan moving forward?
Yeah, so obviously when we're starting building this technology, we try to use auto ML to cover as much as we can. But I think technology is great, but essentially it still comes down to the data, right? I think in the industry, when people are talking about auto ML, I think in the traditional way, they can see auto ML as can they do feature engineering automatically? Can they kind of go through different models and do model parameter sweeping, things like that? I mean, yeah, from that regards, we already achieved. But I think what is more interesting or more challenging is how can we automate certain pieces on the data sets rather than just doing feature engineering, right? For instance, when we look at the data, right, we see some outliers. Can we make sense of them? And how should we deal with them? Should we just remove them, or should ask for human inputs, or we do something else? And also, when we look at these data sets, right, or look at this data from certain industry, can we quickly aggregate other external data sets as well? For instance, if a beverage, obviously weather is very important. So we need to understand this is the data from the beverage, and the weather is actually very important. But also, if the company says, I'm actually doing forecasting 6 months out, then the weather won't help, because weather forecasting usually just for next few weeks. So I think the understanding of the data and how to apply certain techniques to automate the process of data, the aggregation of other data sets as well should be also part of the auto ML. I think nowadays what I see from other solutions, which is they actually are lacking a lot of capability on that regard. So all the efforts is on the model, but essentially they have to understand this. If they're serving financial industry, that might be okay, because those companies, they're actually on the forefront of technology. They have a very solid data infrastructure. Everything is already in good shape. However, if you look at retail, manufacturing, consumer packaging goods, they are in a different ball games, and people are still dealing with a bunch of Excel sheets. You have to aggregate everything together. I think dealing with those type of data sets should be part of the auto ML as well. But it's not easy task because a lot of times, obviously, you can starting you can starting from certain points, those actual scenarios we usually see, but once you work with the clients, better about their business, better know about their data sets, you try to add more and more tweaks to your RML, and hopefully in the future, if we see something similar, I think the system can do the job instead of we go there do the job for them.
So so basically, what is still going to be like a significant problem, at least for the foreseeable future, is the fact that most of these non-tech companies or non-like tech forward companies are not necessarily having the same level of like consistency in how they're storing or manipulating the data input. So
Yeah.
would you say that like building up a robust data pipeline would be sort of like an important pre-step for any of these companies that want to start implementing a tool or start using AI in their processes?
I think so. Obviously, if you look at those big companies that are already kind of investing, especially their IT team, they try to build infrastructure across different business functionality, which is great, right? Essentially, they can put everything together within their ERP system, their CRM, or their data lakes, and which make apply AI technology much easier, right? But you also have a long tail. Look at like e-commerce. There's so many sellers out there, and obviously, if they're using platform like Amazon and Shopify, right? All those data sets is actually they have a standardized format, standardized way of storage. I think consume them is also very easy to do. But if you look at other like physical retail who has the retail stores and maybe are still running a spreadsheet, things like that, I think the first thing go there is not try to evangelize the usefulness of the AI, is try to kind of put all those data together and build a solid data platform first before they can really think about anything any interesting application on top. So
do you get any like pushback when you try and like if a company I mean, I'm not going to ask anything too specific here, but have you ever like reached out to a company and then realized that you do need to do quite a bit of work on the data like pipeline side, and how does that conversation usually go?
Yeah, so I think it comes from two folds, and obviously from the sales perspective, we're always trying to prioritize the clients, right? You always try to evaluate how sophisticated they are. Are they already data ready, right, to use AI or not? Obviously, we have to figure this out, but from engineering perspective, we always want to talk with those clients to understand if the problem they have is the data they have is quite generic or not, or just very specific to them. If it's quite generic, I think probably it's worse for us to go back to the blackboard and to think about it. Can we have the right tool or have the right technology to solve some data problems? If we could, that's great. We still go and approach those clients, and I think those people, they can help us to build a better product. If it's a very specific, I think we'll probably just deprioritize that client, just approach later once they are actually in a better shape in the future.
Yeah, that makes sense. Oh, Klay, actually.
I just wanted to jump in here. First of all, Avi, you asked that question much nicer than I was thinking about it. I was thinking of asking Yuan about any companies you worked with where you looked at their data and you went, oh God, like where are we going to start? But that's okay. We don't have to get into that. But my follow-up sort of to this conversation. So it seems like the AutoDL, the automated deep learning stuff, has been proven to help businesses across, as you've talked about, various industries.
Yeah.
You mentioned in the Forbes article how one of the core aspects of the tool is to, quote, allow business users tasked with forecasting to use latest AI technology without coding or data science skills. So again, for a task so large, what went into making something so complex accessible for the production manager of one of these companies with no ML or coding experience to be able to analyze and forecast this properly?
Yeah, so when we design the software, obviously we do not want to design another Visual Studio, right, for the machine learning. And, there's a lot of tools out there. So what we try to do is just quite simple. What if we can build something like Excel? What if we can build something like a Tableau? I think for a lot of business users, I think obviously they know you're using AI, but they obviously don't understand how AI works and the complexity behind the scenes. So what we try to do is not to expose anything to them, and I think for them, because they understand their business very well, they understand their data very well. So what if we just give them Excel, and they can input all their data sets, no matter if it's a bunch of data records from CRM or a bunch of data set from the Excel sheet. And once they have all those data sets together, and the software can combine everything by looking at their keys, join keys, things like that. And for the users, they basically just tell the system, okay, this is the data sets I have for you, and I like to know my future demand for next X amount of weeks, and on the product level, on the country or channel, something like that. And just few inputs, and I think we'll just be able to crunch in the numbers and present the result to them. But I think one of the interesting thing is, I think that we take a little bit longer time to figure out is, I think when we build the application, it should look like more like a business application instead of more like a technology product, right? So that means the business app means we have to understand their flows, like how they look at the data sets. After we produce the forecast, how they can do the slice and dice to see if the forecast is actually is pretty close to their expectation. If it does not, can they override? If they override, can we really know why they override? Can we learn this in the future? I think that actually takes a little bit longer time for us to figure out, because we have to talk with the business users, understand the business problem, understand the flow, then have those things to be reflecting the software. So, but for the other ML technology, I think it's all behind the scenes, and you don't want to talk too much. Obviously, for some people interesting, we obviously love to share more things, but a lot of people, they are not very tech savvy. They're not even don't understand how machine learning works. Just I think the segments we're actually talking to is not that sophisticated. So that's why we try to do everything very simple, like using our iOS app, just doing a few clicks, they can get the job done.
I like that approach a lot. I feel like that's a very clever idea to sort of package it the same way that people are used to, and go, oh no, it's like Excel, except the results are much different. I feel like that's probably much more beneficial than trying to approach a new business and say, hey, this is a brand new technology that you've never seen, but we promise it works. It's like, I don't want to deal with that, trying to learn something new.
Yeah, especially I think obviously if you see other AI companies, so a lot of AI companies are actually selling their solutions to the IT department. Let's say data lake, right? So obviously the only department they can sell to is actually IT. They talk to CIO, and they are doing company-wide deployment. Obviously, those people, they have been in the technology world for a long time. They therefore were thinking, they understand the problem very well. But for us, it's a little bit different, because we're talking to the business users, right? And they're not tech savvy at all. So, and we're not supposed to use very technical terms when we talk with them. We have to use their languages. And then if we talk using their language, I think the software needs to, behave as whatever they're using at this moment as well. So
yeah, the software also needs to talk their language. Otherwise, it's going to be lost in translation, right?
Yeah, because they're not very sure. Because a lot of people, if they never done machine learning, they never understand the benefit. It's always, they might be interested, but they might not be a serious buyers. And but if you can build the software that they get used to, they can learn very quickly, then it will be a different story.
Yeah. So actually, in terms of like using it for particular applications, how do you guys handle like recurring training, or like keeping a model up to date, or using it as like a more active prediction or forecasting tool, as opposed to just building it one time and then seeing what it is in 6 months and then starting again?
Yeah, sure. So I think in the AI, I think a lot of people working in the industry, they embrace the idea of open source. I definitely respect as well. So when we build those models, obviously we look at what is going on out there in the field, and if they're useful, we can probably make use of them. And but I think the challenging thing over there is if you look at some people, they're actually publishing certain papers, they say, oh, using my algorithm, we have seen X percentage improvement, but usually those improvements very data specific. So when we look at those technologies, we want to do a little bit more comprehensive evaluation across different data sets and to see if we can see the result consistently. If that's a case, we probably can include that algorithm into our total model stacks. But at the same time, we also try to build our own models as well, especially when we're dealing with some of relatively sophisticated companies who have more data to make sense to use. And sometimes they have not only just time series data sets, they have multiple time series data sets. You can think of transactions, time series, price change, promotion, the website visits, right? They're more like multi-time series. And also you have other non-time series related like product attributes, things like that, right? So in these cases, you don't see out of the box model that can handle like different data types. So that's why those piece of models actually we build in the house. Obviously, we routinely upgrade it if we can use those models on certain clients. We don't see the performance we like. We go there, we go to drawing board, figure out what's going on, then we try to improve the model. And this will be a continuous work. On the other side, I was also talking about we try to build certain derived data strategy or derived data or derived model strategy. So, and obviously, I think the requirement here is we use existing models. We train across different data sets, and we evaluate those performance, and we try to build another model on top of that can learn the relationship between the data characteristics, the way we actually build the feature engine, build the model, and the final performance, right? And this derived information can help us, to do less work in the future if we see something similar, and also recommend more useful information to the clients rather than let them try to give us everything. And obviously, this part will be improved continuously. And usually, we have the model on the top to do that. We retrain it once a month, something like that. So, but overall, I think in the machine learning, it's the overall field is actually moving very very fast. There's a lot of things out there, but also there's a lot of noise out there as well. I think for us, we just have to spend more time to kind of understand those new algorithms and try to see if they actually can make sense or not.
Yeah, speaking of like model ensembling or like using certain derived models to do certain feature transformations before feeding them into your other models.
Yeah.
Like you mentioned you make heavy use of that, but what sort of like thoughts go through your head when you are deciding when to do that and for which features versus when to just use a larger model?
I see. Yeah, I think if you look at Kaggle competitions, I think all those data sets is already kind of clean structure, and also the only way they look at it is look at your scoring board. It doesn't matter how complicated ensemble you could have. It's always the best as long as you can improve few percentage. But for us, in reality, right, there's other factors we need to consider. The cost of training the models, and is it worth to to bring additional data sets, and maybe we will improve like 0.1%, but from business perspective, maybe it's not worth to do actual work to get this 1%. And also you have to consider, are we doing line forecasting, or are we doing batch forecasting, right? For instance, if we work with certain clients that are only doing forecasting once a week, I think that's fine. You can build a pretty complicated models, ensemble models, and we can produce better results. But essentially, the model needs to put into production system, needs to serve as API. And if we're doing daily forecasting, across the few million products, that's running on some very costly and will be time consuming. Let's say if every day they have to rerun the whole they have to run across all the products. We have to make sure everything can be completed within 24 hours. And sometimes you have to have certain buffer as well in case you don't get the latest data sets 12 a.m. in the morning or maybe 2 or 3 a.m. So I think, when we're building those ensemble, we definitely have to consider those things as well, because it creates a lot of latency, complexity, and the training cost. So I think, for us, it's more like a case by case. And if we don't have to do, I won't be too crazy about it. So.
All right. Yeah. So there are definitely quite a few things that need to be taken into account. But when do you try and anticipate what the output or effect on the performance of the model will be before you begin that process? And how do you anticipate that? Because obviously there's quite a few potential outcomes that could occur.
Sure. Yeah. That's why, I was actually mentioning earlier. So when we build this derived data strategy, derived model strategy, this is actually one part of as well, because think about it. So you have this data sets A sitting over there, and you can build X model of ensembles out there. But do you really want to try all the possible combinations out there, right? Do you really want to sweep all the parameters out there? So what we try to do is obviously initially we have to do more experiments, right? But later on, after we run a lot of ensembles across a lot of data sets, system tend to understand it better. For this type of data sets, you just have to run certain ensemble rather than everything out there. I think that's definitely helps, and we just keep doing this, and more data sets we see. I think the system should get better and better to pick a better starting point rather than randomly. So then you have to run a lot of on some models. So, and cost is very important, especially obviously now we actually focus on the big enterprises, and this year we're actually launching a relatively lighter product specific for the e-commerce on Shopify, on Amazon. And obviously those are relatively small sellers. I mean, they're not going to spend big bucks to build very complicated models, and we probably won't be charge high premium, more like low price entry, go after volume. So we have to be very careful about how we can save unnecessary computational costs, yet we can still produce relatively good results. So you have to find certain balance between the cost and the accuracy.
Yeah, that's definitely a very it's a significant problem with most AI companies now when they're trying to develop different techniques. It's always the larger collection of trade-offs, both within the model itself, the data set, but then also the strategic and larger long-term goals of the company and the business use case.
Yeah, but I definitely see the values out there. But you all have certain other factors you have to consider.
Do you guys ever use openly the open source versions of some of these models to do semantic analysis or something, and then use those as a base for some of these?
Yeah, we do. I mean, because obviously some of my clients, they are pretty ahead of the time comparing to other peers within the industry. So obviously they're already using some of the open source libraries. So if we go there and we pitch, so obviously we need to show what is different. So usually what we do here is we look at the open source libraries. Usually we use them as a baseline, and if we we're doing forecast, we'll say we give the same data sets to those open source. Those are actually the result they produce, those are actually other results we produce, and what's the difference. Usually we do those type of things as a baseline. I think it's much relatively easy to persuade client in this way if we can show them how much relief we can have. But on the other side, I still want to emphasize, I think model is not just thing. I think data is more important. That's why we're not just producing models. We also become a data aggregator as well. So we work with a lot of external data aggregator as well. So we try to, because we understand our clients not like all those big internet companies, they have a lot of data sets, and the company we're dealing with, they obviously they could have internal data sets, but if their business is actually impacted by external one like social media, weather, GDP, employment rate, policy, stuff like that, and how can we find ways to quickly get those data sets from my clients and combine them with my with whatever they all provide. So essentially, we also build our own external data repository and gradually increase the data we hold on our site that we hope those things might be beneficial for some of the clients.
I see. And that probably is helping this new leg of OneClick as well, right? With sort of the entrepreneurs, if you will, on like sort of Amazon and smaller services.
Yeah, definitely. Yeah. So I think data strategy and model strategy, they need to run parallel. So we don't want to just focus too much on the model. I think the data is. The more I was actually doing machine learning, more I realized actually data is actually even more important than the model. We kind of shift a lot of focus as to make our product to become more adaptable to dealing with different type of data sets and to try to make use of all the information out there.
Absolutely.
Do you guys use like internally? Do you guys use any like AI or ML techniques to try and make other predictions about how your company is going to be performing or what data you're going to need for a particular type of project or anything like that?
Yeah, sometimes we do, right? Especially we do certain marketing campaigns running on different channels, different keywords. So we do. We use some models to see if we can learn something out of there. Yeah.
Do you think you can like for those learnings, do you think that they may apply to other companies as well? Like when you
I think the problem with us is like we're still, relatively small companies and we don't have enough data sets. And I mean, obviously, I think if we have more data points, I think definitely might be beneficial to other companies. But I think, every company is a little bit different. So, we probably can cross-learning, but to which extent, I think still we need to figure out.
So the biggest challenge maybe is for OneClick and just the process in general. What it sounds like is still accessing proper data, like more the better, if you will, but also to the point where it has to be obviously it has to be good. It can't be garbage in, garbage out, as you mentioned, right? That seems to be the biggest issue.
Yeah. So we in this regard, we try not only to be application providers for them to do forecasting. We'll also try to become a data provider as well and combine both the application and the data together. So
do you have any like tips about how to like set up data if you were going to go to a company that hasn't touched a computer since 1985? What would be their like process to create a good data situation to start using like modern?
Yeah, sometimes we do. I mean, if we go there, we see what they have, and we'll usually share our experience and tell them, okay, for other similar companies, usually this type of these are the type of data sets they usually collect and what type of infrastructure might be suitable for them, and if they're thinking about how to use the AI in the future, what might be the set of data they need to collect before they think about it. Yeah, we usually give certain recommendation on this, but I think the tougher part, right, which is more challenging is not. I think the data is important, but I think when we come to use AI to solve that business problem, I think I'm seeing a big gap about the business problem they have and technical problem that we can use to solve it. Because essentially a lot of business problem is not like you can use one model to solve it. It's not like you're doing Kaggle and you just build a model, right? So over there you might need to use different models to do to solve that problem. I'll give you one example. Let's say if we go there, we look at the data sets. Obviously that business might be promotion driven, right, on certain products, but unfortunately he doesn't have enough promotion. They might have just few months of data points, right? Essentially, if we just take, whatever sales data they have, and we produce forecasting, it won't be accurate, right? Because promotion is a very important factor. However, they don't have enough promotion. Then essentially we try to see, can we really go back, do certain extrapolations to predict where in the past they might have a promotion. So in this case, we go there, we need to figure out this, and we figure out, can we reproduce the possible promotion in the past before we can do forecasting. I think this is one example. Or we have seen certain outliers, right? Let's say COVID, right? COVID, last year. Obviously, if you look at those numbers, they might be quite different from what they usually see. And obviously, if you keep using this data after everything goes back to normal, then the model will be biased. They will say, yeah, you're gonna see a big jump usually in February. So in this cases, we shouldn't, think about forecasting model first. We need to go there and we try to extrapolate. What if there were no COVID? What might be the sales looks like? Things like that. I think that's important as well. And also you have cases, and especially in e-commerce, they're actually launching a lot of new products, always new product. And because they try to get market share, they try to see if they can find a very hot product that have a big sales. And in this case, you don't have enough data sets, right? And obviously, there's no way we can train big model. In this case, we have to use other ways. So, okay, even if you don't have enough data sets, maybe you have now. Maybe this is before the product launch. Then we will see, by looking at product attributes, can we find some similar products? Can we use those similar products historical data sets as a baseline for us to do the forecasting on those new products, right? What if they have just a few weeks? Can we also do certain clustering from something similar in the past? So I think there's extra work needs to be done before we formally run the forecasting model. Is about how can we use different techniques to improve their data qualities, to remove those outliers. So things like that. I think those are actually more complicated, and sometimes we have to talk with them, and because sometimes the way we correct those data sets needs to be compliant to their business requirement. So that usually takes a little more time. So so that's So if we see these kinds, usually we do is we try to evaluate how much time we need to spend with them, and see if we can put a priority over there. If they are not that ready, if we need to spend a good amount of time, maybe it's not the best time to talk with them now, maybe later, a year later might be a better timing.
And this is kind of tangential. Right now, we've been mainly focusing, or I guess your OneClick has been mainly focusing on companies with large existing product catalogs. But for example, like, could you frequently get, or have you ever gotten like somebody who wants to use forecasting to do prediction about potential new products that they want to enter into the market and how those might perform? And if so, what kind of like challenges do you normally face? Because for those instances, you don't really have any data specifically about that product.
I think to be honest, if we go there and we have the company say, okay, your forecasting solution sucks, and we have a better one, I think you probably will get a relatively poor response because they thought, we already have something, I have been selling this product for X amount of years, and even if you can improve 5%, maybe, it's, we don't see too much business values out there. It might be the case, right? But I think for a new product, it's a different ballgame because it's unsolved problem. And if you look at forecasting, I think our advantage from modeling perspective, right, is they are using statistical models or very basic machine learning model. We can use deep learning models. They were just using internal data sets, but we can use both internal and external. But still, I think the gap is not that big. However, if you go to the new product, I think it's a different ballgame because for right now they doing new product launch is everything is by that experience basically, and if people they left the jobs and they launch a new one, maybe they will be way off, and there's not a systematic ways to do so, and it's actually a very nice problem to solve. Especially I think nowadays you see more and more D2C brands coming coming onto Amazon, eBay, and they have to figure out the new problem. And I was actually reading certain stats. And if you look at Amazon, I think the product that has less than 2 years lifetime on Amazon is already over 20%. That means like people or companies or those brands are just keeping launching new products. I think figure out the new product forecasting is very much essential for them because they have to figure out how much initial launch they need to prepare, inventory, raw materials, things like that. So obviously, yeah, the problem is we don't have enough data set perspective, from that perspective. That's why it's even more important for us to doing cross learning, right? Let's say if they are launching a new product that is relatively new to the company, but not relatively new to the industry, then if we already working with other companies within the field, let's say this new company try to launch sparkling water, but it's sparkling water is no new product for the industry, then we can do a little bit cross learning to understand the pattern. I think that could definitely help to do better forecasting. However, if it's a new product and it's even new to the industry, then I don't have a solution yet for it. It's like they're launching a iPhone killer. Who knows? So there's always certain limitations that you can do on your product. So
yeah, that's very insightful. We are almost out of time here, so actually I do have 2 questions remaining. I'm sure that you may have some very good insights on this. But basically, where do you think the space is going to be going in the next 5 years? And I'll ask the second question later, but yeah.
You mean space from AI perspective, like AI industry?
Just the AI industry, but I guess more specifically for your target customers and how what the adoption of AI or this sort of tool will be like in the next.
I think I'm actually very positive, optimistic about what we're gonna see for the next few years. I think obviously the segments we're targeting is few years behind those internet technology companies. But I think they're getting there. I think right now they're not talking about using AI a lot. They're more talking about how they can do digital transformation, how they can put everything to their data warehouse, data things like that. I think they're already in the middle of the whole process. I think if we look at probably 2 or 3 years out there, I think they should be pretty data ready in that regards, which is great. But also I think the whole industry, AI become more like a commodity, right? I think in the futures, if you go there and just saying I have a better algorithm, just want to do the work, because essentially I think from an algorithm perspective, it needs to, it should be I don't think you can have a killer algorithm. I think definitely collective intelligence has more value. That's why you see a lot of people, they publish papers, they share more code, things like that. I think the company strategies gradually shift to the data strategies. You think about I'll give you one example. Think of a company like Google, right? So I think that part of the Google is not on the algorithm behind the scenes. It's more about the data they have. All those people that go there, they search because the more you search, the better they understand who you are. Then later on, if they try to run certain advertisement, they can be more targeted. I think for us, the data strategy is to be able to dealing with a lot of data sets within the industry or targeting to see if we're able to really learn something across different data sets and to be able to provide the best data insights to my clients. I think that could give us more advantage comparing to the advantage we can get from the algorithm, because data has as long as they actually incorporating more and more unstructured data sets, I think there's more insights we can extract. I think those things are more valuable from competitive perspective.
And as my second question, which is going to be completely unrelated, but for the budding data scientist or AI ML engineer, what sort of advice would you give them about if they're transitioning from the Kaggle very well structured data they've been sort of learning off of when they want to start applying their knowledge to real world problems, what sort of things would you like give them as advice about how to best approach that?
Yeah, I think that's actually a very good question. So when we work with some my existing clients, I've seen usually two structures, and I think the first structure is more common than the second one. So the common one is actually they have a centralized IT teams, and the IT teams they might hire a bunch of data scientists, and this data scientists might work on different projects, things like that, across different operational departments. The second model is more like each department they actually have their own data scientist. So I think I obviously definitely value the second approach better than the first one, because essentially I think everyone in 5 years I think should have the basic capability. People coming from the college understand how the AI works, how the training models, the feature engineering, and it become more like a commodity. I think the most important thing for them is to understand how the business flow works and the business impact. If they improve 5% accuracy, what does it mean from business perspective? Are they saving X amount of money, is making X amount of money, and also why they're seeing those patterns within data sets and how they can correct them, right? Because a lot of understanding can be converted into the way how they construct those feature engineering, how they construct models, how they change those loss functions, and how they run optimization. I think I see a lot of data scientists, they have basic skills, but they don't have the enough business know-hows that can definitely reduce the effectiveness of their work. So if I have certain suggestions, they have to be patient, right? Because I understand a lot of data scientists, they think building model is actually fancy works. They rather reading a lot of literature, but essentially if they want to solve the real life problems, and a lot of them out there, they have to talk with the business people. They have to be patient. They have to understand doing a lot of data exploration is important. Rather than right now, I think the tendency is like, you guys hire a bunch of data engineers. I just want to work on the clean data. It just doesn't work in this way, because how can you make data clean? I think the requirement is you have to understand the data better. But how can you understand data better? You have to understand business better. So I think they have to be more patient, more open to do more data explorations, to talk with the business people, to get those business insights, then go back to the drawing board to see if they can provide the data quality, the model performance, and things like that. I think I definitely want to give them this advice.
Yeah, sounds good. Klay, do you have any other questions you want to ask?
No, I will just say it was a pleasure, Yuan. I learned an exponential amount as someone who does not have technical experience. This was a really delightful conversation. I feel like the future is bright for OneClick and sort of AI processing in this way. So thank you so much for joining me and Avi today. I really appreciate it.
Thank you for your time as well. It's a great time to chatting with you both.
Likewise. So yeah, thank you again to Yuan and Avi. I've been Klay for the Metabob Podcast, and we'll see you back here soon. So
all right, see you. Good luck, guys. Bye-bye.
Yeah, see you.